Alright, so problem 8.5-21. It's this problem right here. We have to solve 8.4-12 using the moral circle method. Okay, so alright, without further ado, let's begin. First of all, it's important to identify certain things. I usually just write this. Let's choose a color, maybe purple. Okay, so we know that this is 0 MPa, right? And we know that this tensile stress in the y direction is negative 40 MPa. We know that the shear stress right now it's negative 30 MPa. Okay. And these are some of the stuff that we already know. And now let's move on to calculations. Okay, so we know what x is, right? X, maybe I should use this. Yeah, x is the point on the moral circle is this. So x this, and then y is in the y direction. Tau xy. There's a negative in front of it. Okay, so draw this real quick. Okay. Now we can draw some points. Maybe we use the make this heck. Yeah. Okay. Now we can change this a little bigger. Okay. Maybe to a different color. Maybe the green. Let's keep it red. Okay. So this is 0 and this is negative 30. So we're going. So remember, this is a positive, right? And this is positive, or sorry, just tensile stress. Okay. And let's change that a little bit. So we got 0 and negative 30. Okay, so 0, negative 30. So 1, 2, 3. So somewhere here. Okay. And now let's look at this one. So this is negative 40. So let's say 1, 2. I don't know. It's not to scale, obviously. I don't have the engineering paper with me, but do use engineering paper, all right, when you're doing this. Okay, so and then here's the other point. So here's a point, and let's draw a circle between them. Let's see, maybe this should go a little small. Perfect. Here we go. And let's, I don't know, change this to, yeah, to green. Okay, perfect. So I have this circle. Now this is the basic moral circle has been constructed. Let's say, we say this is x, the heck. This is x and this is y. All right, and the middle of the circle, I'm sorry, this circle needs to be adjusted, my bad. Okay, let's see, so we have to draw a middle line before that, sorry, my bad. To draw a little middle line between here and to this point. Okay, and change that to a different color, and then now we can construct a circle based on this, right? So we can draw this like that, maybe. Yeah, somewhere around here. Okay. Wait, that should be somewhere in the middle, though. Maybe like that. Yeah. Okay. So basically how I would draw this like on a paper is we draw like a triangle like that, and then draw the circle according to that. Okay, so this is not an art class, so we're just gonna leave it like this and keep moving. All right, perfect. So we have x, we have y. Now let's try to figure out some stuff. We know that this average equals x plus y tensile stress average equals x plus y divided by 2, and that is negative 20. Okay, so here, as we said, is negative 20 and 10 and 0, sorry, which is MPa, and we're trying to figure out what R is, right? R is negative, well, this is negative 40, so negative 40 minus negative 20, okay, square, plus this is negative 30 MPa squared, and square root of these, so it's a 3, 4, 5 triangle, so this is 50 MPa, okay, so 50, oh, sorry, no, this is a 20, 2, 3, well, it's not a special circle at all, my bad, misread it. This is 36.05 MPa, okay? And now we have the basic setup. Now we have to determine the principal stress. So how do we shift this moral circle, which is this current state that's being projected over here, into the principal stress, so principal plane? We shift x towards, you know, this horizontal axis, but always you know, remember to shift into a certain direction. Now, looking at this plane, we know that just by this circle, this is the maximum, and this is the minimum tensile stress that we will ever get, right? So this is tensile stress 1 and tensile stress 2, right? On this circle, on this, you know, axis, this is maximum, this is the minimum, okay? Since this is the positive side and this is the positive side, okay? So, well, we got the middle, and to calculate these 2 points, we got the middle, negative 20, and then just plus r, right? This is the distance of r. So, in that case, 1, tensile stress 1, the maximum is negative 20 plus r, and then this is negative 20 minus r. So plus r, I don't know, negative 20 plus r, that is negative 13.6, sorry, negative 16.05, and wait, sorry, positive, my bad, and then minus r, well, that is negative 56.05 megapascal, okay? So we got these two, fantastic. Now let's figure it out what the so the angle, right, from here to here to the maximum, right, because we're trying to get it to the principal plane. So but the angle that's being shifted, we have to calculate that angle. So it's pretty easy, right? Right angle triangle, it's we have the opposite, we have the adjacent, and this angle usually in the circle, it's 2 theta p1. P is stands for principal, 1 stands for this 1 point here, or the maximum, and 2 theta is because 2 theta will be, so if we calculate to be 70, it's actually just shift by 35 on this I guess a section of the member. That is because during the transformation equations, we had, you know, we made an equation based on, you know, cosine 2 theta and sine 2 theta, right? So on the circle it's 2 theta, but you know, in reality it's just theta, because theta is what we're looking for. But yeah, we're trying to find what this is, so we turn, so this would be, you know, inverse of tan, this is x, so sorry, so how much we go up, that's negative 30, or just say 30 in this point, and excuse me, and then by how much, this is negative 20, 0, so that's 0, right? We don't have to worry about like this or that, right? We just only have to worry about, you know, this angle from here, right? Everything is in perspective. So this should give you 56.03, oh 56.3, and this is 2 theta p1, right? But we have to rotate theta p1 on here, right, as we discussed before. So theta p1 is well, that divided by 2, which is 2815, right? Theta. Okay, so we figured out what that is. We're going into this direction. Well, technically, if you're spinning this way, this is a negative because this is clockwise, right? So we can add a negative up here. And theta P2 is, we're going to shift that. Well, okay. We haven't get there yet. Let's do this one step at a time. So we get this angle, which means from here, this is going to spin about 20. So this is 45, yeah, 28.15 theta. So this is perpendicular to this, so the square will look something like this, right? With this being the 16.05, and then this is 56.05, right? Going in these two directions. So we spin it like this. Now, okay, so we're done B, right? Sketch the proper orientation, right? We did that, and now we have to go to the maximum shear stress. So we have to go to another plane. Now, how do we do that? Is basically, we can decide this through intuition, or yeah. So since this is tau, right, we're trying to find the shear stress, and this is the shear stress. And so this distance, so the maximum shear stress we can get is this point over here, right? And how do we do that? It's just straight down from the middle, right? Straight down from the middle, and that's what the value is basically just, it's R, right? This value, it's R from the center. So tau max is actually just R, which is, let's see, what is that? What is R? Oh, 3605 MPa, right? So we have this, and now, while we're here, we figure out the maximum shear stress. Oh, sorry, we determine the shear stress, now we determine the normal stress. The normal stress is basically just, add this line, a straight vertical line. What is theta? What is the shear stress? I mean, tensile stress. It's this, right? It's at this point, which is literally, so let's say S is average, right? Because this straight line is just correspond to this point over here, which is -20 MPa. Okay, so now we know these, and let's find out the orientation. So we already went this way, so this is negative, right? -28.15, and then we have to spin x up to here. Okay, x up to here or up to here, it doesn't really matter. Okay, you can spin it from here to here, or you can spin from here to here, but we have to base it, from the original plane. Okay, so we have to involve theta p1 with this rotation, include this with this rotation. Okay, so theta p1 is -28.15, and the positive and negative, sort of, it doesn't really matter as long as you draw this clearly and you know which way you're going, right? So I didn't, supposedly it should have been -30, and then it gives you a -28 angle, and then that's how you get the negative. But if you draw the circle clearly, and you know where everything is, you sort of can just decide. Okay, so this is going -28.15. Wait, sorry, my bad. We spin it to theta1, right? So this would be this angle over here, which is -56.3 theta. And that is going to +90 or -90, right? So plus or minus 90 is going to give you 2 theta P2, right? I'm sorry, no, not P2. It's going, so this is X is going to spin all the way to here. We don't want that. We want S1, right? S1 is just shear stress, shear 1 or 2, which is plus minus. Since both of these has a 2 in there, we can divide it by 2, which is theta 1 plus or minus 45 is going to give you theta S1 or 2, right? Okay, and that is another orientation. well, we can just calculate it from here. So 28, negative 20, 15, I'm sorry, negative 28 point, 15, minus, I don't know, we can just say minus 45. That is going to be negative, so let's say, sorry, S2. This is going to be negative 73.2 theta. So it's going to spin another 72.2, right? On top of that. So in that case, we will get, let's see, we will get, something like this, right? Something like this, because this is another data and this is perpendicular. Okay, so somehow we want to spin this like this, right? So we will have a direction going over here, which is, what did we say? Yes, 36.05, and then we have another one over here, which is 36.05 megapascal, right? In these two directions, and this is, no, that is wrong. No, negative 20. My bad. Sorry, negative 20, which is in the negative direction. We have to care for that. So this is negative 20, and this is negative 20 megapascal. Okay, so we spin it 2 times to get to different strains. So when we get to the principal stress, it gets to these 2 places. So the shear stress is 0, and then we spin it again to the maximum shear stress plane to get the maximum shear stress, where the other 2 equals to each other, and it's just equal, gives you the normal average is the answer. Okay, Moral Circles has a lot of stuff. Just practice, 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 and you'll be good. But yeah, hopefully this was helpful. Good luck on your studies, and I'll see you in my future videos. Bye.